Hey there, I'm Sophie and I'm an example of a neural network.
And I'm Sufi. I created Sophie.
When you think about it, humans are smart, but slow, and computers are dumb, but fast. The neural network is as smart as a human and as fast as a computer.
Neural networks enable computers to think and are based on the human brain. Just like how the human brain has neurons to process electrical signals, the neural network has nodes to process numerical data.
The purpose of a brain, regardless of computer or a human, is to take inputs and predict outputs. Now what's interesting is the neural network is better than the human brain at predicting some things, and we're going to dive into an example of that. This neural net takes 4 inputs in matrix form and diagnoses heart disease, where 1 is yes and -1 is no. But first we must train it. These lines are values called weights and serve as the neural net's memory. Now let's consider that we want to make this car out of Play-Doh, and these are the steps. Why start at step 0 when we can take a small random step forward and get closer to the final product? Therefore, I want the weights to be random, so the neural net could learn faster. Our first training data is that of Sam, a 25-year-old man with high blood pressure and heart disease. When we take the dot product of the inputs and weights and normalize the data by mapping each number to a value between 0 and 1, we get the hidden layer, which helps the neural net relate the 4-dimensional input to the 1-dimensional output. For the final output, we'll dot the hidden layer with random weights and normalize, giving us 0.18, which is not near 1. So the neural net will increase accuracy by backpropagating, which is optimizing the weights using stochastic gradient descent, which is minimizing an error function. Here's how it works. We know that when error is low, accuracy is high. So let's minimize the squared error function. And since Sam has heart disease, the value for actual is 1. However, we need something to make the error drop, and the weights do this by changing their values such that the error function converges to 0, meaning the neural net has learned Sam's data. To learn more trends, we'll train the neural net on a diverse group of people, and continue optimizing so when the neural net gets a test input, it will use the optimized weights to reflect what it learned to make a powerful, accurate prediction. Many programmers have programmed neural networks just like ours that are more accurate than physicians at diagnosing heart disease. Practically speaking, different types of neural networks have slightly different structures and strengths, but share the same underlying math, much like how humans are wired as visual or auditory learners, but share the same brain. Sophie is a blend of different types of neural networks predicting her face, voice, and expressions by using vectors, sentences, and images as inputs.
Hey.
Even this piano is predicted by a neural network. And even you've used a neural network before. Hey Google, are you a neural network?
Yes, I use neural networks to deconstruct the complexities of speech. That's how I understand what you say.
We're at a stage where neural networks can do almost all the heavy lifting for us. So the more we use them, this synergy of man and machine can propel us into a brighter future.